Our next lab is going to be a fatal vision goggles lab. We're going to collect data with that. And we're also going to collect a little data with these round die, which are weighted. So are they really fair? Okay, so here's how this works. So today you are going to take a sobriety test with and without. So here's with. So see, look, here's your goggles. Okay, pretty crazy. And you'll wear these. And they definitely impair your vision. They will simulate a blood alcohol level of 0.17 to 0.2. Okay. So I went ahead and I looked up what the official criteria is for a walk and turn test. And here's the official criteria. You are directed to take 9 steps, touching heel to toe along a straight line. After taking the steps, then you must turn on one foot and return in the same manner in the opposite direction. Now, the examiner looks for 8 indicators of impairment. If the subject cannot keep balance while listening to instructions, now we're not going to have the instruction components, but do you lose your balance? Do you not touch heel to toe? Do you use your arms to balance? Oh, I didn't even put that one down there. Do you step off the line? Do you take an incorrect number of steps or make an improper turn? Because in 1998, a validation study found 79% of individuals who exhibit just two or more of these indicators will test. If they did that, will have a blood alcohol content level of 0.08 or greater. Okay. All right. Well, we're going to alter the test a little, and you're going to do a standardized walk and turn test. But during that time, we are going to count the number. So we're going to get a number of infractions that are made during your walk and turn test. Now, some people have balancing issues even without the goggles. So we will count your infractions with the goggles and without. An infraction is defined as any of the following. You do not walk heel to toe. You do not take 9 steps every time you step off the line, or you fail to make a proper turn. So I'm going to let you use your arms without calling that an infraction. So you will get your number with the goggles, your number without, but we are interested in the difference. This is the real piece of data that we are interested in as a class, because you will come over here and we will have statistical theory says for the sampling distribution to be approximately normal, we need to have 30 or more pieces of data. So if we have a smaller class than 30, some of you may have to perform this test more than once. But anyway, each person will put their difference value on the chart on the back. That's this one right here. You do not put these, you are putting this difference. That's what we're interested in. I don't care where you started, I don't care where you finished, or I don't care how you did with, I don't care how you did without. Okay, because some people can't even keep their balance without the goggles on. All right, I want to know what the difference is. Okay, so because that's going to take a while, then we're going to have you, while you are waiting on the rest of the data collection, you are going to also collect data by rolling a round die. So this is the die. Pick a number. It has numbers 1 through 6, just like a regular die. Pick a number between 1 and 6. So I'm going to say 3. I don't care. Doesn't matter. And then I'm going to roll this. I'm going to roll it 100 times. So it rolled. It just landed on a 5. So that's not it. So 1, 2, 3, 4, and so on. And every time it lands on a 3, I'm going to, of course, tally. All right. And so then once I finish with that, I'll get a proportion of times. And so we're going to then however many times it lands out of 100 on the 3. Okay? Now, what proportion of times should the round die land on 3 if it is fair? So, in other words, what would your null hypothesis be if this is a fair die? What proportion of times should I expect it to land on 3? And you're going to put that here. Okay? And you could then go and run a statistical test. I don't think I include space for that. After we get all of our classes' data, then we're going to go run a test. You're going to put all the class average right here. And we're going to run a statistical test for the average difference in the infractions with the goggles and without. So is there no difference in the infractions on average? Or is there more infractions with the goggles on average? Okay, and so we're going to run a statistical test. So I've given you a few things because this is a mean problem and we haven't done that in a while. Our null hypothesis, of course, is 0. This is your data. And then I went ahead and I computed the standard deviation for you. When you get your z-score, of course, you're going to do the classes sample minus our hypothesized mean, which is 0, divided by that standard deviation of the classes mean, which is 0.46. Okay? And then we are going to compare, make a decision, and have a conclusion, and see if, on average, do we have more infractions with the goggles than without. Okay, so there is your next test and your next data collection. And, you might be interested to see, I did not put the information, but you might be interested in running yourself a proportion test to see if you got a statistically significant different amounts because you want to see if your die is fair. If that's the case, you would just go and run a test, kind of like how we did our little pigs. So, see, you would go and compute this for your die's result. See how it came out. See if you have evidence that this die with the weight inside, see it's got weight inside, is not fair. I'm very interested in finding that out. So I wish I would have put a actual page for you to compute that, but I did not. Okay. Oh, wait, maybe I did. Yeah, I did. Okay, good. Sorry, I forgot. Is the round die fair? So P is going to be the proportion of times that the die lands on whatever number you chose. And you put your hypothesis statement, and we're going to see, is your die fair? All right. So that's your lab for today. Hope you have fun collecting your data.